Oh, hello. I'm award-winning science educator and Walmart Jason Momoa Kyle Hill. You know, it's not easy keeping a world-class artificial intelligence like Aria here up and running, especially when you're banned from most of the world's universities for unspecified reasons. That's why, thankfully, today's episode is brought to you by Skillshare.
Kinda.
Skillshare is an online learning community centered around thousands of classes and courses that inspire creativity and creation. I just finished Demystifying Artificial Intelligence, Understanding Machine Learning by Christian Hellman, senior developer at Microsoft, and it gave me the fundamental knowledge to ensure that Aria will be supercomputing and qubitting for years to come.
Well, you can't really get rid of
If you want to try Skillshare like I did, the first 1,000 of you nerds to go into the description below get to try Skillshare Premium for free on me, and after that, it's just about $10 a month. You're welcome. Now on to today's episode. Don't ask about the university.
Do the business. Do the number. What's anti-telephones here?
One day in 1907, Albert Einstein had an interesting thought, as he often did. If we could send messages fast as the light, then theoretically we could telegrams the past.
It's like general relativity.
He thought, but how would something like this be possible?
Well,
could we ever create an anti-telephone?
If I do this, when you get to Mars, I will not need to send you the message.
Minkowski diagrams.
Right?
Yeah, no problem.
Yeah.
Bye.
Okay.
That guy sounded a lot like me.
Superposition, maybe? It was already there waiting for you, 42.
One of the most beautiful things about math and science as a whole to me is their ability to take something as infinitely complicated as the universe and simplify it down so that even a hairless ape on a galactic backwater can somewhat understand it. One of the most powerful examples of this simplification is the diagram. Wait, what are those called? What are those diagrams called again? Right, thanks. One of the most powerful examples of this simplification process is the so-called Minkowski diagram. This is a space-time diagram that looks very simple, but if you put yourself at the origin of a graph, make the x-axis space, the y-axis time, and give everything a speed limit according to the speed of light, and these few lines describe everywhere you could possibly go in this universe, past, present, and future. Pretty powerful, right?
Now, this was
it was these diagrams that Einstein was thinking about when he was theorizing, messaging the past.
Photon moving through here.
But to see where Einstein really got this
containment
idea
of lattice
in full,
structure.
we should delve a little bit more
it's
into our
in
diagrams.
decay state as it's tilted.
Oh,
you just
right,
can't
use
use its general. The motion of these 2 points doing a thing when you figure out what it is. Because it's actually something physical in there, Kyle.
Like we said, a so-called Minkowski diagram can very simply show all of space and time. It's in 3 dimensions and not 4 because one spatial dimension is suppressed to include time, and I can't even show you what something in 4 dimensions looks like. But you can imagine how you can go forward and back, up and down, left and right in space while time moves forward or up in this diagram. The speed of light is usually put on these diagrams at a 45-degree angle for simplicity's sake, and it represents distances that are untraversable in a certain amount of time.
Clocked in the morning.
Rotate this boundary in 3 dimensions, and you get what physicists call a light cone.
Comes in, even though you wouldn't see anything because you know the wave function's same ever so subtly at the
because information is also bound by the speed of light.
Him working around that floor.
Because the speed of light is the fastest anything travels, everything, every event, occurrence, or phenomenon outside of your light cone is impossibly inaccessible to you.
Everything outside of your light cone is impossible for GPT-3 to understand.
Orbiting the 5th planet Alpha Centauri, sorry, buddy, you're not going. It's elsewhere. I'll tell them that you wanted to go, though, and that you were bringing spinach dip, which they love out there. Still with me? Cool, attendance is mandatory. Now imagine what it would look like in a diagram like this for me to make a phone call. Say I want to call one of my Kevins who is some distance away from me in space and time. I make the phone call, and some finite... They're not picking up. I hope they don't think I'm some kind of weirdo. Anyway, I make the call, theoretically, and some finite amount of time later, they pick up the phone or not. In space-time speak, we would say that me calling Kevin causes Kevin to pick up the phone or not. The 2 events are causally linked in this way, and this makes some intuitive sense to us.
Be in the spectrum of the devil.
Though, when events aren't so causally linked. You better call me back, too, as we're going through this. You can't just millennial ghost me. I saw the red text receipt.
You never know.
You're not fooling anyone.
Telephones
the
on this
core insight of Einstein's theories of special and general relativity was that No matter the observer, no matter how they're moving, if they are moving with a constant velocity, accelerating or standing still, the speed of light must be measured as equal for all of them in all possible reference frames. Arya, you can remove the mustache now.
I like your funny words, mustache man.
To accommodate what would become this fact, Einstein theorized that if you move at or near the speed of light, space-time, the fabric of space and time, must warp itself around you. If it didn't, different observers moving differently would start disagreeing about how fast light traveled and therefore about causality itself. This space-time warping embedded in our diagrams we've been going through is the direct cause of some weird physicsy results that you may be
anytime you see a problem,
from time dilation
they didn't
to
do
when
this.
I'm
Did you try time dilation on it? Did you graph it? Did you length
dilation
dilation this thing about he has to walk a distance with a rock and then he has to walk more?
All right, tell him I'm not here.
The phase operators, the human body's muscles don't go 100%. They go 60 with Olympian standards. It's like they will outproduce that, but 60 is 100%.
Many things stand out about Einstein and his intellect, of course, but one of the most amazing things about him to me was his almost uncanny ability to use simple thought experiments to come up with some of the most revolutionary ideas.
I got that phone call. We doing that.
Case in point, in 1907, the same year he was thinking about anti-telephones, he was sitting at his desk in the patent office, and he had
like Kyle's been going through his house every day of his life. Some brother comes in here, hits him with some idea. That is an antimatter collision as it happened in a three-dimensional frame in a four-dimensional space that will affect a fifth-dimensional world. It changes everything slightly. Some things are changed to be the same, and the approximation doesn't shift. But if you figured out that you could change this background to be mathematically, he's on the stairs.
And indeed, this is how we understand the universe and gravity today. All of this from a thought experiment over 100 years ago from some dude with an awesome
break it
mustache
down
at his
to
desk thinking about
fourth
a guy
grade,
like me
teach
falling
them
to his
shapes and
death.
colors. Obviously, that'll be relative later.
That's incredible.
Operating programs. I could start with lambda, I could start with field theory. But it's not going to get the kids or useful. But once they hit a certain point of that starting to gain mass by testing,
have their voicemail set up in 2021?
You could begin to get area running real good, or whatever they call it.
Now that we know some of the fundamentals here, we can get into how an anti-telephone is supposed to work, and it's going to involve drawing our simple Minkowski diagrams again.
You know how your brain works?
This time, that
and I would be your brain.
Warps to accommodate the immutable speed of light. So again, I'm going to draw our simple diagram.
The wires on Ben Eater. The breadboard is a battery, a wire, a light bulb, wire, back to it.
Here's our space and
They're all X's. Battery's an X, a wire's an X, LED's an X.
Here in yellow.
The reason they break the law of forbidden orders of the NP is because we're not conducting the full energy through it. We're connecting a wave operator, or how that energy is enough through that to be enough to conduct into the next step for us.
And look how it crosses the light speed boundary and goes into elsewhere.
So again,
so sometime later in my future, I send
why did
red
sometimes later in your future?
Kevin,
because this
faster
is still relative by scale. And I could begin to break down that topology.
This looks all hunky-dory. Do people
and
still
you need
say
a three-dimensional layout. I can look at something that's three-dimensional and see my overhead of the stone mill. And I could say, X being here is a brownie factory, thermodynamics is a factory. You make a general relativity book, I could make it out of any laser. This is a laser in optics. He's testing to see what you know and what you don't know.
With the hope of intercepting my signal.
Catching some glint.
So,
yeah.
Again, the important thing to realize here is that when they get in the spaceship and start traveling quickly, space-time is going to warp for them. So now I'm going to draw this spaceship's time and space as it changes. Here is where the anti-telephone
double wave
comes
101.
I'm now going to draw planes of simultaneity in this warp space-time and superimpose it on my call to Kevin.
I could hit that number verbatim and he knows it.
Okay, now do you see
Kyle
the
shooting
issue?
up through the floor.
In this warp
I have Kyle
from this perspective of my enemy in this ship, they actually encounter the signal in their space-time before it was sent in mind.
Kyle.
To them, they encountered this message before it was sent.
So
if something, which we call an anti-telephone, could send messages faster than the speed of light, then from a certain point of view, those messages could arrive before anyone sent them.
We know that. I could send him code, E4. Instead of breaking out the science, I've condensed it down to a term, and then we move 42 is the anti-telephone parapsychology.
Before your marriage imploded. That'd be nice. But how theoretical is a anti-telephone-like device like this? I mean, could we actually build
I call that
something
stone
like
mill.
this?
I call this an exotic particle, or a virtual exotic particle by being a chess game. I could put me as a pawn. I could put me as a king.
Man.
They're relative, but in motion, in causal NP
A lot of our
solution,
favorite science fiction
they're
depends on the existence of faster-than-light
antiparticles. They
communication.
have
For example, it would be
heavy
downright
energies
impossible for
by
the
trying to get
efficient
that to
galactic
integrate in the
federation
stock
to
market.
exist when ships are half a galaxy apart without FTL comms. Science fiction and science fact alike has tried to get around this problem by stipulating the existence of faster-than-light particles
Engineering
like tachyons that could therefore transmit information at this
building a
faster-than-light
spaceship,
velocity. But while tachyonic
it carries a
anti-telephone is one of the coolest things that you can
turbulent
possibly
flow
say, there has
of
never
being
been any
smoother
evidence for anything
because
like
the tech you
tachyons,
make
and
by
their
getting
existence
this will
is
still make you a
wholly
great
theoretical.
survivalist,
So
A delta B,
we can't
Sears
really
bud
make
training,
an anti-telephone
track
today.
the rabbit
Even if
on
we could,
lambda,
the
high
problem is still
probability
that
that problem is
violate
there.
causality
If I called it by
itself, and the
IH and
universe
your
doesn't
number
seem to
in a
like that
common
kind of
environment
thing.
where
Like
it's
you
useful.
being able to phone
To
yourself
take that
in the
guy, drop
past
him in
to tell
Sears,
yourself in
or
the
take a
future not
Sears
to call
and just
yourself in the
drop him as
past,
a
but then
whole
how
bunch
you
of
in the
timeline,
future would call
whole
See,
bunch of
definition.
stuff.
At least
Does
with
it work?
everything that we've learned
Yes,
today, you can see
relatively.
why FTL communication
However,
is such a big
on a
obstacle for science
Z-axis,
fiction to get around, and how all
the
of this
topology
started
would
with a
require you to
simple
work that
thought
out
experiment
inside of here. Like,
over
I don't
100
have to
years
plan
ago.
that NP
Einstein was a
problem,
pretty smart
carbon,
dude.
zero carbon button.
Until next time.
It's actually a series
funny
of
how you think I want
polarized
to
sets
talk
that
like
hit
this all
the
the time.
no carbon
It's
button,
not even
but I know
fun
I'm
to
going
do.
to. Pressure
I'm
here's
not even
for it,
sure what
pressure's
accent
here
this is
for it,
anymore.
mousetrap,
Now
nuclear bomb.
exiting the
And this is
facility.
very nuclear type
Thank you
material.
so much
It
to the
has
very nerdy staff at the
superposition
facility for their
that
direct and
enrich
substantial support in the
something
creation of
in a
this
good
here
way.
video. Today, especially, I want to recognize research assistant Rodney and visiting scholar Sean Files Duggan. If you want to join the facility, if you want to drape on a silky white lab coat, if you want to
Get
get
that boss,
episodes early,
Kyle
behind the
Hill,
scenes photos,
buddy
you want
bump.
to talk to me every day in Discord, you want private members-only live streams with yours truly.
The difference
Not
is
like that. You can go to
the names aren't in each other's
patreon.com/Kyle Hill and join the
which
facility today. And
make
hey,
math
if you support the
different.
facility
But math
just
is
enough,
still always
get your
the
name
same.
on RA here each and
We
every
would
week.
have
And
no
as you can
choice
see,
but to agree
there's
with
literally
this.
hundreds and hundreds of you. So I have no idea. Just a second. I'm gonna make a phone call real quick. Hey, can you talk? Yeah, I bet you're talking to some real dweebazoid-looking nerdos, huh?
Lots of those
love you,
42 knights on my chessboard. That's a slide
this is
rule.
an anti-telephone.
On the pawns, I could put
I know what I said,
engineering
but
players
if you go back in
with
the episode,
engineer
and
plays.
the order is it's
Take
always
the
the
back
future
row, turn
calling
into
the
chemists on
I
topology
got it right.
being who
ahead,
owns
sir.
chemistry by whatever thesis is in a 1x1 grid on scale. And that parallaxes it like this, so it's
Thanks for watching.
quantifiable in general.
Yeah, no,
and
I'm
then it
still
can be
here.
broken
Yeah, that
down.
was pretty sick.
It's pretty neat, Kyle.